Hi everyone, my name is Satya and this is a demo about Yaci DevKit. In this demo, we are going to build a smart contract and we're also going to write the Offchain code to test our smart contract in Java. The Offchain code will be in Java, and then we are going to use a local Cardano node created by Yaci DevKit to test our smart contract. So to start with, first we need to install Yaci DevKit. To do that, we need to download this zip file from release section. So once it is downloaded, you have to then unzip it here. And you can now go into the folder. To start the DevKit, you have to use start.sh script. What it does, it starts Yaci DevKit Docker Compose, and it also starts the viewer, which is a explorer for our local network. So then the next thing you have to do, you have to run Yaci CLI shell script, and now we are inside Yaci CLI prompt. Now we are ready to create our new network. So we do create node -o is for override. So it will create a local Cardano network with one node. And then we can start our Cardano node. So if you notice here, the Cardano node is already started, and now it's starting Yaci store, which is an embedded indexer for our local Cardano node. So now everything is ready. Now if you do tip, you can see the network is moving. Now if I go to the browser, we can check our explorer here. It's a, and you can see the blocks are minted, and it's basically 1 second block, so which is very useful when you are in your development phase. Okay, so the first thing we're going to do is we're going to write a smart contract. For this demo, we're going to use the Hello World smart contract. We can find it in Aiken's website. And what basically this particular smart contract does, we have to first lock some fund at the script address with the datum. And in the datum, basically, we have to specify the owner. And to unlock this fund from that UTX, so you have to send a redeemer with the message "Hello World," and you have to sign the unlock transaction with the same owner address. So what we can do, we can copy this and we can go to Aiken Playground, which can be accessed to this play.aikenlang.org, and we can paste our smart contract here and try to compile it. So now this is the compiled code for our smart contract. So our on-chain code is now ready. So what we can do now, we have to write our off-chain code. So which will be in Java. So I have already created a application. It's a Maven application, but it's just an empty application. There's nothing here. So first thing you have to do is you have to define some dependency. So what we can do, we have to define first dependency you have to define is Cardano client leaf, and we're going to use 0.5.0 beta 2, and the second dependency is Cardano client leaf, Cardano client backend block force. We're going to use block force backend because Yaci DevKit provides endpoints which are compatible with block force. So it provides all required endpoints for transaction building and transaction submission. So we can use block force backend for to test with Yaci DevKit. In the third dependency, we need to add is Aiken Java binding, which will help us to evaluate script cost. And yeah, so that's it. So we need Cardano client leaf, Cardano client backend block frost, and Aiken Java binding for this demo. And then now we are ready to write our Offchain code. So let's call it hello contract Offchain Java class. So the first thing we have to declare few fields here. The first thing we need a sender account, right? So for that we need to define sender mnemonic, and let me copy paste the existing mnemonic here, and then we need to create the sender account, which is quite easy. You can use account API to create sender address, and for receiver we are going to use this address. So we are going to lock let's say 10 ADA at a particular script address, and then we're going to unlock 10 ADA from that address and pay the unlock amount to a receiver address. And then the compile code. So for compile code, I'll go back here and copy and paste the compile code here. Okay, so I hope it's okay. Okay, so now we have to define few more things. The first thing we have to define a backend service. Our backend service, as I mentioned, we're going to use block force backend service, but the API endpoint will be pointing to Yaci DevKit's API endpoint, which is running at localhost 8080 APIs plus v1. You can get this URL from Yaci CLI. From online form, you can just do info, and you can see here Yaci Store API URL endpoint, this one. And the key or the project ID could be anything. And then finally, let's create a Pluto script from this compile code. Yeah, there is a utility class Pluto's blueprint util. For using that, you can create a Pluto script object. So compile code, and then you can pass Pluto's version. It's a v2 script. And let's also create this script address, and we can do address provider. Let's go get enterprise address, and we have to pass Pluto script, and then network is testnet. Yeah, I think I need to do to page 32. Okay, our script address is steady. The first thing we're going to do, we're going to write our lock function, right? Which will be a simple transfer transaction to the contract address with a datum and some fund. So the first thing we need to do is we have to create the datum, right? So if you still remember our datum in the smart contract, let's verify it again. So our datum will be basically datum has a field called owner with payment key hash. So let's do this. So what we can do a constructor Pluto data of the first constructor, and then we can do a byte Pluto's data and sender dot get base address, which returns a address, and then we can get payment credential hash dot get. Yeah, so our datum is now ready. Now what we can do, we can create a TX. So this is the quick TX API. We're going to use quick TX to build our transaction. So, and then we can say pay to contract to the script address. Amount we are going to log is 10 ADA, and then this is our datum, and this will be paid from this sender address. Okay, and then we have to define a quick TX builder. Again, I have to pass backend service to create it, and then quick TX builder has few methods like compose. We have to use this transaction compose, and then we have to define a signer. The signer will be here, signer provider, signer from sender, and yeah, that's it. Then we can do just complete and wait. Here we do system dot out dot system.out.println. Yeah, and this will return a result object, which will have transaction ID if the transaction is successful. So we're just going to print the result object. So what we can do, we can just print the result object here. Okay. So this is our lock transaction, which is quite simple. So we're just paying to the contract 10 ADA and with the datum, right? Required datum. So similarly, we'll have another method. Let's say unlock, and in the unlock method, we're going to unlock unlock the amount whatever we locked here. For this, we need few things. We need to find the right UTXO or script UTXO. So we need to define a UTXO supplier, which can be easily created using backend service. .get UTXO, and then we can use a script UTXO. We can use this utility function class script UTXO finder and do the find first by inline datum, pass UTXO supplier, script address, and our datum. So I think we need to define this datum here again. So I'll just copy paste here. Okay, so this should now return a UTXO, or let's call it script UTXO. Okay, so we have our script UTXO. So now invoke this contract. We have to define script TX. This is again a quick TX API, and to new script TX. The first thing we have to do, we have to collect from this UTXO. So we use this function script UTXO, and then we have to pass the redeemer. So one thing we forgot to do here, we have to define a redeemer. So redeemer is again a Plutus data here. So we call it redeemer. Yeah, so Copilot already added my code, but I think I need to change this to this. So it's a constructor Plutus data, first constructor, and the value of message is hello. Well, let's go back to our contract again. So you can see there is only one field message, which is a byte array. Okay, and then we have script UTXO here, and we pass the redeemer. So after collect, we have to pay to, let's say, address receiver, and the amount we are going to pay is 10 ADA, and we need to then attach pending validator, which is our Pluto script. That's it, and then we have to create a quick TX builder like we did last time, and using backend service, and then quick TX builder, compose this script TX, and then a few things we need to do here. First thing is we have to, let's say, instead of sender paying the fee, let's say the fee will be deducted from receiver output here. So we define fee pair as a receiver in this case, but the transaction will be signed by the sender. So we have to define with signer, signer provided from sender, but by default the fee pair is the collateral pair, but as we don't want to do that because we are not going to sign the transaction with receiver, we have to explicitly define collateral pair here as sender dot base address. And then we need to do one more thing. We have to define required signer, which is again sender dot get base address, because we are validating that in the smart contract. And finally, we need to use the X evaluator, Aiken transaction evaluator, to calculate script cost. If you're using block post endpoint, we don't need this, but if you're using Yaci DevKit, Cardano node, then you have to use this because there is no endpoint in Yaci DevKit to evaluate script cost. So you have to do it offline. But it's quite simple. You just need to use Aiken transaction evaluator and pass backend service, and finally to complete and wait system out println, and the whole thing will basically return a result, and if it's successful, we'll get a transaction ID. So we're going to simply print this result here. Yeah, that's it. So we have a lock transaction, you have an unlock transaction, and finally write a main method, and let's do hello world, hello contract Offchain, and hello contract Offchain. First we are going to lock it, and then we're going to unlock it, right? So I'll comment out the unlock part. So first let's try with that lock. So let's run this. So now if you see, we got a insufficient balance exception because the sender doesn't have any fund to transfer. So what we can do, we can copy it and go to Yaci DevKit again. And Yaci DevKit is a command called top up, using which you can actually top off your test data, right, to any address. So let's top up like 50,000 data, which should be enough for our, more than enough for our demo. And now we'll try our transaction again. Okay, so the transaction is now successful. It's 1 second block time, so it's quite fast. Now if you go back to our Explorer, you can see this is the transaction where we paid 10 ADA from the sender address to script address. And if you go to the JSON view, you can also see the datum here. Okay, so this is the one. So you can do the same thing from the command line. Let's copy the script address. If you go to command line and do UTXO's script address, you can see there is only one UTXO available there. Quantity is 10 ADA, and there is some inline datum. You can also pretty print this inline datum. Yeah, now you can see there is only one field here, the owner field. So now the next step is we have to unlock it and send the unlock fund to receiver address. So I just uncommented this unlock method, and I'll try to run it again. Yeah, so it's successful. Again, now if you go back and check the UTXO in the script address, it's gone now. And if I go to the Explorer again and check the last transaction, so you can see the 10 ADA moved from script address to receiver address, and the fee was deducted from there. So fee was paid by receiver output, not by sender, and that's what we want, right? And yes, so the same thing also, you can go here and you can also verify it from the command line, right? And yeah, that's it. So you can we just saw how you can how you can create a new Cardano network, single node Cardano network on a local machine without using any external service, and how you can basically test your on-chain code using off-chain Java code, everything on a local machine, right? Without using any third-party service. Yes, and finally, if you want to just reset your network, start from scratch again, you can just do reset, and it will just delete everything from the current network, and it will just start the network from the beginning. So it will mean the block 1, block 2, again it will start from the start. So if I refresh this Yaci viewer now, you can now see your blocks are being minted from. Yeah, it's in epoch 0. Yeah, so that's it. That was a quick demo of Yaci DevKit. Hope you like it, and thanks for watching.